Hello everyone, Ewan from Elixir Experts here. Today I'm going to show you how the Windows time slice method of delay analysis actually works in action. I will discuss its reliability and dispute resolution in a follow-up to this video. Okay, let's get into it, and please like and subscribe if you like it. The Windows time slice method of delay analysis provides for developing a series of baseline program updates or revise contemporaneous program updates in discrete periods of time, often referred to as windows, and recording any slippages to the completion date as a measure of critical delay arising in each window. Project records are then examined to assess precisely which events might have caused any critical delays. In order to demonstrate the technique in action, I've shown an as-planned program for the construction of two buildings, Building 1 and Building 2, each comprising a substructure and superstructure. The start date is the 1st of January, and completion is forecast to be achieved on the 31st of August. The program also contains logic, allowing the critical path to be identified. In this case, we can see that at the start of the project, both buildings 1 and 2 are critical to completion because both sequences are continuous and forecast that completion is to be achieved on the 31st of August. I have recorded the base details of the program in a table below to use as a benchmark to assess the impact of any delay events. The table shows the date for planned completion, the 31st of August, any critical delay, which is likely to be 0 in the as-planned program, and what is critical at the time of the analysis, the substructures of Building 1 and Building 2. Next, the program is updated with progress. The first update I have chosen here is the 1st of March, 2 months after the 1st of January. This defines the first window, which I've highlighted and called Window 1. I would add that program updates should be submitted at a frequency required by the contract, and it is more common for this frequency to be monthly. However, I have chosen 2 monthly intervals here for greater visibility and clarity. When progress is added to the program at the 1st of March, we can see that the contractor had progressed the substructure of Building 1, shown in blue here. But we can also see that there had been a 1 month or 29-day delay before the substructure of Building 1 could be completed. Building 2's substructure progressed as planned. This month-long delay to Building 1 pushed planned completion out from the 31st of August to the 29th of September. And since the substructure of Building 1 is driving completion, it can be said that a critical delay of 29 days has arisen as a consequence of delays to the substructure of Building 1 in Window 1. I've also highlighted the critical path in the as-built section of the program to show the delay clearly through Building 1. Next, the program is updated with progress at the 1st of May, 2 months after the 1st of March. This defines Window 2, where it can be seen there has been a 2-month delay, or 61-day delay, to the substructure of Building 2, whilst Building 1 progressed as planned. The 2-month delay to Building 2 pushed planned completion out from the 29th of September to the 31st of October. And since the substructure of Building 2 is now driving completion, it is critical at this time, as recorded in the table. It can then be said that the effect of the 2-month delay event is a 32-day critical delay to completion, i.e. there is a critical delay of 32 days as a consequence of delays to the substructure of Building 2 in Window 2. The reason why the 2-month delay only caused a critical delay of 32 days to completion is that the Building 2 substructure was not initially critical at the start of the window, and only became critical when it started driving the completion date mid-window. I've highlighted the critical path through the as-built section of the program to illustrate this more clearly. Next, the program is updated with progress at the 1st of July, 2 months after the 1st of May. This defines window 3, where it can be seen that there has been a 32-day delay to the start of the superstructure of Building 1, whilst Building 2 progressed as planned. This 32-day delay to Building 1 pushed the completion of Building 1 out from the 29th of September to the 31st of October, but did not extend the overall completion date further, since Building 2 had already pushed overall completion out to the 31st of October. Therefore, there is no further delay to completion at this time. Although it is evident that Building 1 has become critical at the 1st of July. I've also highlighted the critical path in the as-built section of the programme to show the critical path running through Building 2 in Window 3. However, is this right? The answer here is it is right, but programs need to be reliable, so the analyst should be alert to any flaws or changes in the program activities, durations, logic or progress reporting. So let's return to Window 2 to examine the sensitivity of logic changes. It may be noted that there is a finish to start relationship or link between the substructure and the superstructure of Building 2, i.e. the substructure is required to finish before the superstructure can begin. If at the end of Window 2 this logic link is adjusted for Building 2, so the superstructure can commence 1 month or 31 days before the finish of the substructure, instead of after the complete finish of the substructure, it would result in Building 2 only causing 1 day of critical delay to the overall completion date, which slips from the 29th of September to the 30th of September. Now when we move to Window 3, we can see that the completion date slips from the 30th of September to the 31st of October, meaning that the delay to Building 1 superstructure is shown to have caused 31 days of critical delay. Previously, there was no further critical delay arising in Window 3, so it is evident that the results of the Windows time slice method of delay analysis can be quite sensitive to logic changes, with different activities appearing critical and different delays being shown to arise. I will just toggle the program for Window 3 to allow you to see the difference in the critical path as a consequence of the logic change. That's it. I will leave it there and look out for the follow-up to this video where I further discuss the reliability of the Windows time slice method of delay analysis and what to look out for. Thank you very much and have a great day.